It's not just one or two, but there could be far more than we ever thought. But how many are there actually? And where are they hiding?
The majority of black holes in the Milky Way are stellar black holes. These are the incredible yet terrifying remnants of massive stars' deaths. Imagine a star far larger than our Sun, at least 8 to 20 times its mass. For billions of years, this star burned its nuclear fuel at its core. However, every star has its limits. When that fuel runs out, the star's core loses its outward pressure and gravity, always dominant, will win. The core collapses incredibly fast, triggering a violent supernova explosion, perhaps one of the most energetic events in the universe. But the story doesn't end there. The stellar core remaining from that supernova will continue to collapse, compacting matter to an infinite density at a point we call a singularity. And around the singularity forms the event horizon, an invisible boundary marking the point of no return. Not even light can escape gravity's grasp there. Now, because black holes emit no light, detecting them is a huge challenge for astronomers. We can't see them directly, so we have to rely on their gravitational fingerprints on other objects around them. One of the most common ways to find them is through X-ray binary systems. This happens when a stellar black hole has a companion star very close to it. The black hole's immense gravitational pull will start to steal gas from that companion star. This falling gas doesn't go straight into the black hole. It forms an accretion disk around the black hole, spinning faster and heating up to millions of degrees Celsius due to incredible friction. At these extreme temperatures, the gas emits powerful X-rays, and this is what our X-ray telescopes can detect. Cygnus X1, discovered in 1964, examples of a stellar black hole detected this way. Its discovery helped confirm the existence of these mysterious objects. Another increasingly sophisticated method is astrometric observation. Astronomers use high-precision telescopes to carefully track the positions of stars in the sky. If a star shows a subtle wobble or unusual movement that cannot be explained by other visible stars, this could be a clue to the gravitational pull of an unseen massive object, like a black hole. This technique is relatively new, but it's already starting to yield fascinating findings, identifying more stellar black hole candidates that were previously unknown. And even more unique is gravitational microlensing. This takes advantage of the fact that gravity, even from a black hole, can bend light. So if a black hole happens to pass directly between us and a distant star, its light will be subtly focused by the black hole's gravity, causing the background star to appear temporarily brighter before returning to normal. While hard to predict and very rare, microlensing observations have successfully detected several black holes, adding to the evidence of this hidden population. So with these methods, scientists now estimate there are hundreds of millions, perhaps even 1 billion stellar black holes scattered throughout the Milky Way. Imagine that. That means for every 100 stars you see, there might be a black hole hiding somewhere. This is a hidden population far larger than we ever imagined. They're the remnants of the early universe, constantly moving, unseen, yet possessing unimaginable power. And their existence isn't just a fact, it also influences the dynamics of our galaxy. But what about the biggest monsters, the true giants? We'll discuss them in the next segment. We've seen how the Milky Way is filled with the remnants of dead stars, each an invisible gravitational trap. But among those billions of stars, gas clouds, and countless stellar black holes, there's one entity far larger, far more dominant, and truly dominating the very heart of our galaxy. Something so massive that billions of stars dance around it. This is... At the heart of our Milky Way galaxy resides a supermassive black hole known as Sagittarius A, or for short, SGRA. This is a true gravitational giant with a mass approximately 4.3 million times that of our Sun. Despite its colossal mass, its event horizon is only about 23 million kilometers across. That's just slightly larger than Mercury's orbit in our solar system. Small for its size, yet its density and gravity are truly unimaginable. How do we know it exists? We can't see it, but we see its effects. Astronomers have observed stars orbiting SGRA at incredible speeds. These stars move in highly elliptical and fast orbits around an unseen point. The star named S2, for example, orbits SGRA in just 16 years, reaching 3% the speed of light when closest to the black hole. This extreme motion cannot be explained by any other object than an incredibly dense and massive object that emits no light, a supermassive black hole. SGRA is the gravitational anchor holding the entire galactic center together. So, the Milky Way is home to a far larger population of black holes than we might ever have suspected. Not just the mighty Sagittarius A star, but also hundreds of millions of stellar black holes hidden in every corner of the galaxy. Their existence isn't just a coincidence, it's an integral part of our galaxy's evolution. Supermassive black holes, for example, play a crucial role in galactic formation and dynamics. They can either trigger or suppress the formation of new stars around them. Stellar black holes also influence the dynamics of nearby stars, sometimes even flinging other stars at high speeds through complex gravitational interactions. Is this dangerous for us? On a cosmic scale, the probability of our solar system directly interacting with a stellar black hole is incredibly low. The distances between stars and between black holes are vast, making collisions an exceedingly rare event. So, the next time you gaze up at the stars, remember that amidst that infinite light, there's a darkness far more profound. And it is countless. Our Milky Way galaxy is home to a universe of wonders, and also to some of gravity's most powerful secrets. They are proof that this cosmos is far more complex, far more powerful, and far more mysterious than we could ever imagine. Keep asking questions, keep searching, because in every dark corner of the universe, there's a wonder waiting to be discovered. And that is truly extraordinary. I'm Daniel Aven, thank you for watching. If you want to explore more wonders of the universe, don't forget to subscribe and hit that notification bell for our next videos.